Hello and welcome to this webinar on intelligent mortgage processing with RPA and machine learning. This is part of a series of webinars organized by Royal Cyber on robotic process automation. Royal Cyber is a renowned name in software solution building and integration. In the recent years, we won a number of awards. Royal Cyber is delivering solutions with the help of our partners from over 17 years now. We have a global presence and offices in pretty much all of the continents. I am your presenter today. I have over 15 years of software development and delivery experience. For the past 5 years, I am working in the field of automations, particularly for robotic process automations. So this is the agenda of this webinar. First, we'll see how RPA is evolving and going towards hyper automations. Then we'll see how AI is augmenting RPA and making us achieve the desired hyper automations. We have a hands-on demo on RPA and ML tool as part of this webinar, along with a use case explanation for mortgage origination process. Participants can type their questions in the chat window and we'll try to answer them in the end. So let's get started. So robotic process automation, or RPA, is a software that aims to automate repetitive work, eliminating the need for human to perform mundane tasks like gathering and sorting data, filling forms, perform rule-based tasks. This results in freeing up their time to do more creative and strategic work. So RPA is to create digital workforce, uh, and it is like using software robots that can execute any business process. So RPA is changing rapidly, and it is one of the most talked about IT software fields these days. Now, new models are emerging, and hyperautomation is set to dominate in 2020 and in the years to come. As defined by Gartner, hyperautomation deals with applications of advanced technologies, including artificial intelligence and machine learning, to increasingly automate processes and augment humans. Hyperautomation extends across a range of tools that can be automated, but also refers to the sophistication of automation. That is, discover, analyze, design, automate, measure, monitor, so and things like that. In simple terms, hyperautomation refers to the mixture of automation technologies that exist to augment and expand human capabilities. When we think of automation, terms like robotic process automation definitely comes to mind. But hyperautomation takes an ecosystem of technological advanced tools and combines them to create a new way of work. It means that low value tasks are optimally performed with automation tools, machine learning, and advanced artificial intelligence, so that outputs can be produced automatically and run efficiently with little to no human intervention. Then, together with humans, hyperautomation can create a workplace that is always informed, agile, and able to use data and insights for quick and accurate decision making. So, automation will reach its full potential at the end of consistent process. We like to think of it as a journey, one in which a virtual workforce is deployed by the organization to help achieve its long range corporate goals. Usually, it begins with simple, process driven, highly repetitive manual process that do not need decision making at any stage and move towards data driven processes that need one or more decisions during the process. The cost and complexity also increase when the automations move from doing to thinking. Generally, robots are rule based, but they can now have additional skills like visual understanding of the UI interfaces, documents, and images, understanding context, language in documents and other inputs, conversational understanding to be able to maintain themselves and handle exceptions, analyze data and perform predictive analysis and decision making, be able to do process monitoring and discovery of processes and issues. So these are the new skills robots are now learning by the help of machine learning and AI. So on the whole, we know that RPA bots are like human users, uh, like the hands of human users. They can operate computer applications and perform process related jobs much faster with far more accuracy. Letting these bots leverage the power of brain through AI opens up a whole new world of automations. This makes end to end automations achievable even in more complex and decision driven processes. In this session, we are going to cover two segments of AI and their use with RPA. First, we'll see it by natural language processing and then by data science and machine learning. Natural language processing is a subfield of linguistics, computer science, information engineering, and artificial intelligence, concerned with the interactions between computers and human languages. In particular, how to program computers to process and analyze natural language data. We can use it to understand human user or customers' intention or requirements through verbal or written words or sentences. Integration of natural language processing or NLP provides a humanistic touch to take the human experience to the next level. There are many NLP engines that we can use to train and integrate with the flow. One such engine is shown here, that is wit.ai. It's kind of a free tool available. You can try it pretty easily. It's very easy to use. Here you can see that you can uh, type in the context and different answers your bot or your system needs to understand, and it can understand through its NLP that what the user is asking about. Primary use of NLP with RPA is in the form of chatbot integration with RPA. This is how it works. The customer interacts with a chatbot hosted at company's corporate website or mobile app. The chatbot understands what action needs to be performed based on customer's request. Chatbot calls an RPA bot to perform the actions at the back office applications. So RPA bot performs the actions, then extracts the response or statuses from the back office systems and relays them back to the chatbot, which displays appropriate information in the form of chat messages. So that's how the customer who is at the application, at the chatbot application interacting, and the bot goes at the back end and performs in the back end applications and gets the responses. Now let's see how machine learning is generally used with RPA. As we know, machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience. Without being explicitly programmed, machine learning focuses on the development of computer programs that can access data and use it to learn from themselves. As a branch of artificial intelligence, machine learning refers to systems that can use data to identify patterns and learn from them. Machine learning relies on little human intervention as patterns it uses pattern recognition to know what to do next and optimize procedures. The system's algorithm is first trained using training data and then creates a model. When the model is ready, queries for production are accepted and the algorithm developed during the training is used to predict the outcome. A feedback loop can be put in place to further train the model in case of exceptions or prediction under a significant confidence score. As organizations grow their RPA programs, they will look beyond core capabilities and seek higher value opportunities. By leveraging machine learning, intelligent automation programs can develop solutions for opportunities that were thought to be too complex to automate and needed a human for intervention because now they have power of prediction through machine learning. So DataRobot is one such tool that can help here. With DataRobot, we can train machine learning models to make them take decisions and continue to uh, automate without human interactions. So here in this chart, you can see that first we have some processes, some softwares that we use to automate some parts of our processes. They are ERPs, they are um, tools like Excel and spreadsheets. So we have those, and now then we had robotic process automation there that helped us automate using those tools and do the activities that a human user was performing on those applications. And now we have tools like DataRobot that can understand the decision making process by analyzing history of data and by using the machine learning model developed through the search engines, we can take decisions on the fly while the RPA bot is processing this is performing the processing. So clearly, both RPA and machine learning have the potential to provide great advantages to organizations. So nevertheless, they are substantially different technologies. While robots can improve the speed and efficiency of the process, a standalone robot does not currently have the ability to evaluate the process and make cognitive decisions. As you can see, this flow diagram, RPA bot is fetching data from multiple processes and performing actions in different applications. It is using an ML model to make predictions and decisions. This ML model is continuously being improved by human feedback that is kicking in for exception handling. It is also important to point out that the integration of ML and RPA is a two-way improvement strategy. Throughout the automation process, robots are exposed to huge amounts of data. Should the robot be programmed to store and filter useful data, this feature could be leveraged by machine learning to train its forecasting model continuously. Now let's have some hands-on experience on RPA and its use with machine learning. For the purpose of this demo, I will use UiPath and DataRobot. UiPath is available in Community Edition for a very easy start for your organization. Um, we can use any RPA tool here, but this demo that I'm going to show you will be built on UiPath. So let me explain what this demo will be about. This exercise will be about, will have primarily three steps. One where the RPA bot will read mortgage leads from a system. So it will kind of log in into a CRM application where mortgage leads are stored. We can build a bot to read these leads even from emails or PDF files or any other medium. Uh, Here in this exercise, we'll read it from a CRM system. And after reading those leads from there, and the RPA bot will call a machine learning API built on DataRobot. We'll also show you interface of DataRobot, how that machine learning model is built there. And in the end, the after querying for a result from the machine learning model, the RPA bot will record the results that either it is approved or not. So here you can see a sample CRM application from where the RPA bot will fetch the loan applications or leads. Now we are seeing how we will build the RPA bot. Let's name this bot as mortgage origination. And the first thing we want to do is to read from the CRM application. So we need to open a browser. What would be the URL that the browser needs to open? So I have this file. I'm not hosting this anywhere, so that's why I'm opening it from my own computer. So I'll just give this file path as my URL. Now I need to Okay, now we need to extract this table from this application. So I will click next here, click on any field. It will identify it's a table. So I'll say, yeah, it is a table. It is showing me what it has extracted from this table. I am good with that. I don't have more pages, so I'll not go for defining how the bot should go to fetch data from more pages. So I'll just finish it. Now you can see that it has created a variable by this name here, and whatever it has fetched is stored in this variable. Now what I'll need to do is to take one row at a time in a loop and send that as a query to an API call from DataRobot. So to do that, first I'll create a loop for each row. The name of the variable against which the loop will revolve is extract data table. And we already have the package for API calls called UiPath Web Activities. It is already installed, so I can use it. HTTP request is used for REST calls. I have the endpoint details for my DataRobot API that I'll have to paste here. I'll have to put the security keys and other things that I don't want to show to everyone here. So I will skip that step here for now. And in the last step, what we need to do is, based on whatever result we'll receive here, we will have it in this variable that we'll make here. Let's name it result. The API's response will be received in the variable result now. I'll have to deserialize it because it would be a JSON response. We're seeing this error here because the result variable is not having the right scope. Result variable is here. We can increase the scope here and the error is gone. Okay, so now it can be deserialized using it. We'll have to put the right parameters to get the right stuff out of the JSON. And based on that, what we'll do we'll create another browser activity, and we'll be, we have a Google form that we will use in this demo to record the results from the machine learning API. So this is the URL for that, and we will, what we'll do is we'll open this form in Internet Explorer, and first thing we need to do is to type the application number into the form. We'll go and tell, okay, we need to type it here. And we'll put all the, actually we have already read those application numbers, and they're part of this extract data table variable, and now it is revolving around this. uh, Let me show you where the, so this application number is here. It is the second column. The first column is column 0 and the second is column 1. Since in this loop all those rows of the extracted data table, each of the row is kept in this variable row for each iteration of this row loop. So what I'll have to do is bring this in this loop, everything. And this is how I can access the second column of that table and change it to string to be able to use it here. Now all the errors are gone, and you can see that we are fetching the second row, second column of the row that is being iterated, and we are asking the robot to type that text into the column that is the field that is designated for application number. So let me go through from the top again. First, we are opening the browser with the CRM application, reading the table that has all the leads, and then there is a loop that goes through each row in that table and picks up one row at a time. An API call to the machine learning engine with the JSON query. I haven't made that JSON query here yet. We'll have to create that before we send it. Let me put those steps here a bit later. This JSON, this API call gets a JSON response in return. Then we deserialize it and open up the application where we need to record the responses. And based on the response we receive from the API call, we'll either be clicking approved or rejected here. And we'll also put the probability value of default that we have received from the API call here. So now I'm putting this assign activity on top of the API call. This assign activity has to have this variable that is yet not defined. So let me define it. Now let me show you how the JSON request is being composed. Here we have this assign here activity, and you can see a JSON is being constructed here. The structure you can check here, it's a single line uh, text because of the constraint with the tool. And here you can see different references, different variables that we are using uh, to assign values to different things like zip code. So all these parameters are now uh, will be a part of the JSON, and you can see parameters like state, annual income, and employment length, and other things. So all these things will be part of the request JSON, and the variable that is it is assigned to JSON compose will be part of the body that we'll be sending to the API call, and based on that our response will be received now. So this is the overall flow that you're seeing here. I'm closing the web browser that I opened during the training of this RPA bot. So now I'll run the bot and it will open all the applications and perform the activities we programmed. You can see the test execution started written here. It opened the browser, it opened the CRM. I haven't put any login interface, so it is not required to log in. Otherwise, we would have to program that as well. It read the interface from the CRM. It called the API at the back end that we could not see, of course, and then recorded the response on the Google Forms form interface that we created. It is going to each record one by one, calling the API, and then recording the response. For this demo, the criteria I have placed is that less than 50% if are the chances of default, the bot records it as a rejection, and data on the CRM screen is produced randomly. So I'm seeing a lot of rejections here. The bot that is being run here is not exactly the one that we programmed here in front of you. To save time, I haven't programmed it completely in front of you. I had another copy of the bot that has some more steps, like there's a step of if condition where it checks for the probability it has received for the loan default from the machine learning engine, and based on that it decides whether it has to click on reject or approved. And the number you're seeing in the last field, um, for this case, that is 78 point something, is the probability of loan being default. So higher the number, higher the chances of loan being default. So we need it lower. For any record, if we get it below 50, we will approve the loan, or bot will approve the loan. Yeah, you can look at this. 18, it approved. So there are too many records here, I think. Um, which record it is processing? Let me see this time. 653 in the end. 653. Okay, we are towards the end already. So let it finish, because that's how we'll be able to see the uh, results. We can also have more complex scenarios built through this, where there can be multiple decisions the ML engine will make. Based on that, different scenarios will evolve and different kind of bots will be triggered. So we have worked with different customers for those more complex cases, and that totally depends on what stage of automation you are at. So now uh, we are done with the processing of the bot with all the cases, and let me bring this, refresh this, and get to the responses. You can see these are all the responses that the Google Forms has recorded. All right, so that's it for the hands-on demo. If you try it on your side and find any difficulty and in any of the steps, you can contact us for assistance. Plus, access to machine learning engine is a bit difficult. I mean, DataRobot is not freely available, so maybe that is something you'll find difficulty in getting to. Um, Other than that, you can use UiPath pretty easily by yourself. Let me show you one more thing here. So this is the DataRobot that we use in this demo. Okay. Use of DataRobot is pretty simple. Let me show you that when we create a new project here, we just need to drag drop or open a data file. Any CSV or any form of data would work. And once we drag drop or open a data file here, we can even connect to a database through data source or any file medium. Once data is connected, it starts building its analytics and comes up with models like these. Like, it has presented 89 models for my data with lending club loans, and it also lets you it also recommends you the some models. Anyway, I just used this one and published it. the, you can see the model that it has used. So now we are going to see the complete use case of this mortgage origination automation process. Um, and in the end, we'll take questions from you. Mortgage origination is a multi-step process with a lot of moving parts, from figuring out how much of a loan customer is likely to qualify for, to submitting the loan application, to underwriting and deciding mortgage interest rates. Here's how a typical loan origination process looks like. For most lenders, it is a process of around 20 days. First milestone is pre-approval. That has a few steps. The customer either applies for pre-approval by a phone call or by online portal or through manually filling a form. Bot extracts data from the forms. An RPA bot reads the information submitted and fetches credit report. It also helps calculate the approval limits and preliminary information on monthly payments and APR. By this, we can show the requesting customers what sort of monthly payment and APR can be expected on different terms of loan. Bot also enters this lead into the CRM and keeps it updated. The bot can dispatch email for the pre-approval letter, or it can also help it get printed for physical mail. Now, customer comes in with formal application for the loan. Automation of data extraction from documents, document verification, as well as information verification can be made quick and accurate by RPA bots. We at Royal Cyber also leverage from machine learning tools such as DataRobot to bring intelligent decision making within the capabilities of the bot. The RPA bot is also capable of processing the closing and loan onboarding. The customer is required to apply for the loan and submit copies of required documents. If the documents are fine, the RPA bot picks them and extract required information from them using OCR, computer vision, and artificial intelligence. RPA bot automatically verifies accuracy of information from documents like borrower forms, income information, and W-2 forms. It can also perform identity and asset verification. Additionally, our bot can identify incomplete documentation and communicate errors or omissions to loan officers and borrowers before sending the loan to underwriting. Bot identifies any missing or eligible documents to stop the processing and inform customer and loan officer about it. For risk assessment, bot calls a machine learning API built and published on DataRobot. Our machine learning model is capable of making decisions on the basis of learning it has done by analyzing thousands of similar cases. It is capable of predicting bad loans with a reasonable confidence interval. We can choose to manually look into the cases below a certain confidence interval. DataRobot has dozens of machine learning algorithms to choose from on the basis of what suits best in a specific type of business case. For cases denied, the bot can provide major reasons for the denial of loan so that if communicated, the customer can reattempt after improving on those factors. Cases with positive results, that mean with low loan default risk, are then entered in the backend system by the bot as approved applications. Bot can also process the loan closing and onboarding by accessing and entering details into the other systems and applications. This is how the overall loan origination process time can reduce from 20 days to just a few minutes. For more information about intelligent automation and RPA, please visit royalcyber.com. So now let's have questions from you guys.